Welcome! This stream started a little bit later than I expected, but here we are. So, welcome back to Learning NIM. As always, like, subscribe, comment during live stream, after live stream. Stream will be cut up into smaller videos later. I'm trying to make the videos that I make out of live streams a little bit shorter because first few were like half an hour, 50 minutes, and now I'm going through the material from when we were going through a tutorial NIM by example, and finally I'm getting to something shorter where I can make them, 8 minutes, 10 minutes, maybe 12 minutes, a little shorter chapters, and I think they'll be a little bit more helpful because the first few streams well, they sucked. Well, let's be honest, they absolutely sucked. I hope I'm improving. Let me know if I'm improving or not, if we even have any returning viewers in the first place. Because, that can be taken for granted. And yeah, that's pretty much it. We can get back to what we were doing last time, which is we were finally getting some success when implementing the basic CommonFS actions, methods. So let me first show you the GitHub repo that I made. So you can go to xconti CommonFS on GitHub, and there's a new repo. I just dumped everything that was on the stream so far and did a little bit of extra. Let me show you what I did. So when we go to our CommonFS repository, first of all, I added the .vs code directory where we have settings.json. This is where we configure the official NIM extension. It's if we go NIM, we have the nim-lang.org. That's the official extension, straight from the nim-lang GitHub account. So I don't know who exactly made the repository. I'm sure it's a lot of people, but that's the official one. Okay. And for it to properly work, we need to go, add your settings. You could do that in the global settings for VS Code, but in this case, I just made it here for the repository. So whoever copies it, it should work for them. So sure, not 2020, 2024 copyright, sure. So we don't care about build on save, but build command is C. That's the recommendation. Lint on save, absolutely. And this is very important. NIM project. This just specifies that for this project, what are the entry files? As in, let's say you have multiple packages or multiple applications. You list those NIM files here. In this case, it will be usage NIM. This is the equivalent of what we had this whole hello NIM file that we were still editing. I just renamed it to usage, and that will help this whole NIM suggest give a little bit more proper suggestions, because last stream it was just all wacky. You just couldn't understand that there are more than one file and whatnot. It wasn't very helpful, and with that it seems to be a little bit better. We'll see more if that's true. And then I also added module.nim. This is what I guess will be later. Maybe it will be just, CommonFS, because right now all the three files are still here. We still have CommonFS, InMemoryFS, and OSFS. Well, in the future, we'll be splitting it into completely separate repositories, which will be completely separate packages available through Nimble. But we'll get there. As we're building out CommonFS, for now, it'll be just easier to do everything in one little repository. So, we'll get there. And the last thing is nym license string. As far as I understand, this basically adds this comment to the beginning of each file. So I don't know, Benjamin Dudek. How do you write the copyright? I don't know. We'll suggest something. Copyright, blah blah. Well, it is MIT. Sure, MIT license. Then with new line, we have copyright 2024. Okay. Let's just add that and that'll be just there, okay? This way it'll be clear. It's MIT license, so everyone can use it. As long as it's there's attribution, I'll be fine with that. So that's that. And then second file that we added, we have tasks.json. So tasks is, I don't have a lot of experience with VS Code, but basically tasks.json and the VS Code folder is basically something like configuring what build commands or whatever are available. You can specify tasks that can be run. And this is kind of copy paste what was suggested on the extension configuration. So the first one is this one, and nym build current file. It, I guess, specifies that we use command nym and the arguments for it and whatnot. And this is supposed to help with debugging on the inside VS Code. At some point, I'm sure we want to debug things. So when we'll be doing that, we'll look more into if it actually works or not. Then, let me just check if I have everything here, if we have sound and other stuff. OBS suggests that we have sound, and looks like you can see me as well. Let me just see that message on the bottom bar. Implementing the CommonFS abstraction. Sure, that's good enough. I just added that sidebar because I don't want you to see my taskbar on the bottom from Windows, because it can get messy, and I just added text so I don't have to constantly tout, hey, subscribe, whatever. Whoever can read it, so that's it. Okay. Nobody's watching, so hello, nobody. And cool. So let's continue. So that's a task for debugging, but there's also another one that is supposed to run the module.nym that maybe at some point we'll use. Basically, this is the task to run it, and it should run it, I guess. Output binary. That's how you specify. Because I was looking like, how do you specify output for the compilation command, but I kind of didn't see it. If we'll clear that out, if I'll go nym help, right? We just have that, hey, it's nym compiler. And what else do we have here? The command compile C and whatnot. Documentation, then arguments. We have path to search. We can define those extra symbols. All those things, stack traces, not stack traces and whatnot. There's nothing output unless I needed to do nym C help. No, it just gives the same thing. While this suggests as if we could run it with -o. I'd like that. File base name, no extension. Because right now if you can see, we have this usage nym on the left here. And when we compile it, it creates the usage file, like a binary. Let's remove it. What if I'm going to do nym c-r to c to compile -r to run, and let's do that o, and what they suggested as with this comma here, and let's do bin, right? And we won't give it an file name, an extra file name, right? And what's the file? Usage.nym. Hey, it created a bin folder. Now we have usage here. That's awesome. That means that, because another thing that I added is the git ignore. And I was like, gosh, I need to not allow all the files that are, because I couldn't figure out how to add that output folder. But now we added it, and therefore I don't need to do this gymnastics to basically remove all the files that don't have extension. I could just do that and ignore the bin folder, okay? Oh, that would be so much better. Now we just need to go to the settings of our auto runner, because we have that little extension for run or something like that. Code runner. There's extension code runner, and we're going to go to settings. Let's just get rid of that. We have all the running things. Do we have settings for each language or something? Executor. Set the executor of each language. There we go. Do we have a nym somewhere? Nym. Compile, verbosity, hands off, run. Let's also add O, bin. Okay. Sure. I wonder if I could do the whole thing where we have code runner executor map. Okay. And we go to our settings JSON for the project. And sure, something like that. Let's just copy it. Where's nym? Here, let's copy it and undo it here, because we want it to be like it was before. So we won't edit this one, but we'll update it here. Okay, was 0, hence no, blah, blah, blah. So what happens if I'm going here, remove that usage file? We don't want that thing compiled. I'm going to go to this usage file and do, what was it, Control-Shift-N? Nope, that's new. Control-Alt-N. And run it with proper thing, yes! Awesome. Okay, we just fixed all the problems that I had with the setup. That's good. That's good. So yeah, these are our settings. We have our code runner compiling into the bin directory. Our git ignore now ignores whatever nym cache, nimble cache, and HTML docs are. That was somewhere like recommended for nym projects, what to ignore. Now we just added bin as binaries. So that's that. And we went through all that. What else do I have to show? Yeah, the tasks, whatnot. Then, yeah, added the license. We'll need to edit the README at some point. Usage stays the same, nothing changed here. Although I changed one thing. Previously, when we were creating the file system, we had something like new OSFS. Okay, we executed that proc. But somebody on Discord suggested, hey, instead of doing that, how about you would do it the same way everything else is done usually? OSFS. OSFS, where you just use the built-in language new command or proc or whatever and give it the type. In this case, it could be even just like that. Hey, this is the create new OSFS, and in this case, OSFS should be, and now the name suggest doesn't work, should be of type FileSystem, not the OSFS. So to do that, in our OSFS, what I did quietly, is that I made the OSFS public. Okay, I just marked it as final, and what final means is that we can't, no other new type can inherit from OSFS, so it's final. And then I define my own new, proc, and this crazy thing here. Let me decipher that. So the name of the parameter is underscore. And what that means is we're giving the compiler suggestion, hey, this is gonna be ignored. It's just here for the sake of being, okay? It's just for the sake of being. And then instead of giving OSFS, if we would just have if we would just have this, okay, that will mean that new has to be called with already an instance of OSFS, which is kind of misses the point. So what you can do is say this should be called with a description of a type OSFS. Okay, so whatever would fit into OSFS will be here. But because OSFS is final, only OSFS will fit here. But what it means is that we can actually call it, when we call new and the type OSFS, okay, this suddenly is given as a type, and therefore the nim compiler figures out, you know what, there is a proc called new defined that expects exactly that type. So I'm going to execute that instead of the one that's already defined in the language. So this way we properly override it for that type. And instead of returning OSFS, we're going to return FileSystem, so that in case somebody makes a little other library that would, you know, the idea is that you're writing your code that uses this implementation of the common file system, expecting the file system. You're writing for that so that you are 100% sure that you can change it at some point. And what we do is we basically return the system.new, which is calling, because if I would just do this, okay, it would try to call itself again, and then itself again, and it would just infinite loop of calling itself. If we'll call system.new, because that's where the module system, which is imported by default by the language, is actually hard to get rid of it. The system module is the one that actually implements the new command or procedure. So this way we call that one. This creates a new empty object for us, and we can just return it. So this is actually kind of like defining a constructor. And, you know, we could do fancy stuff here, set something up or whatnot. But, you know, it basically works. So when we have usage, our example of how to use it, the FS is the type of file system. So if we wanted it to be actual OSFS, I guess we would need to do something like OSFS and pass it like this, I presume. I presume that would work. It's just, why don't we have the nim suggest? I wonder. Let me save it, close it, and reopen again. We don't have suggestions of our type. Oh, there we go. Yep, like this will basically give us OSFS, so whatever we'll be doing on the file system, it's the OSFS. While if we just have new OSFS, it will give us file system, which is a little bit nicer because we're forcing ourselves to just use the interface, nothing else. So if OSFS for some reason defines some extra little nifty helpers, we won't have them available by default. This way, if you need to switch your code from, using the OS file system to, I don't know, in-memory one or something else, so you are sure that you're using exactly the same available methods, and you're not like, oh gosh, I relied on that other function or procedure, sorry, and suddenly things aren't working out for you. So, yeah, these are the only changes that happened. And now we made some changes, so let's look what we did. What we did is we updated the getignore and the license and the thingy here. MemoryFS. Let's get rid of that. I'm not sure where that came from. And usage.nem. Sure, whatever. So we basically specified update project settings so that build artifacts go to bin directory. Okay, let's commit it, push it. This binary file, delete it. We don't need it. Okay, whatever happened there. Okay, so this way we're up to date now. All right. Why is it golden? 3 problems in this file. Oh yeah, because we have this extra error here defined, which is not used directly, but we know that it's being used by the methods that actually override those. Okay, so that's done. Now we can continue with actually building our little project. So let's get back to our notes and see where we finished at. So when we plan our functionality, we did the create directory, check if directory exists, and remove directory. And now the idea was to do the check if file exists, remove the file, and create file. And the create file would be nice if after creating it, it would return us the object file that we can use later for, getting more info about the file without passing without having to pass the, what do you call it? The path every time. Because every time we need to pass the path, we need to copy the path, which is again, copying and write. It's not a big deal. But then when we're accessing it, when we're looking for the file, we need to probably do a bunch more checks or, go through the, dissect the path and check maybe normalize whatnot. It's just too much. Okay. So let me actually add a note to like a little to do later. Ensure all paths are normalized before use. I guess we could do that, although I don't know if it's necessary. Don't know, because maybe the user of our library should be responsible for that. So let's mark it as consider, okay? I'll just add it there. It'll be our one decision point. Now let's focus on file exists. Let's see how we can implement that. So we have our 3 methods defined here. Let's copy one of them and call it, and what was it? File exists. File exists. So it will be called on the file system and we'll give it a path. It can raise library error and file system error and probably other things. As we'll be making the actual implementation, we'll be adding those possible errors as they make sense. Right now, I feel like we don't have enough, we don't have enough info to make a proper decision here. Okay, so we have the file exists, and what the comment will be, maybe compile will help, returns true if the file at the specified path exists. If the path points to a directory, it returns false. Absolutely. Perfect. So let's copy that and try to implement it. Let's go to our OSFS, and we defined that method. So file exists. Instead of targeting file system, we'll target OSFS. We don't care about base. We don't care about raises because all that is being already defined. Add the whole method equals, and now we can try to implement it, right? So now how on earth do we check if the file exists? Let's check for it in the, what do you call it? In the standard library. So where's the browser? Here's the browser. Let's go to nimdocs. Okay. Let's actually duplicate it so that we have it as a separate tab here. We go to our standard library. And previously we were looking into generic operating system services, directories, but there's also files, basic file handling, right? There you go. First one, file exists. We just provide it with a file name, and it returns us the bool. Returns true if file name exists and is regular file or symlink. Directories, device files, name pipes, and sockets return false. So that's exactly what we're looking for. Perfect. So sure, copy. And let's get back to our code, and we can actually try to call it. We just need to implement it, right? So we do from standard files, import file exists. Okay, there we go. And now it's complaining and use import file exists, really? Oh, we'll just give it the path, okay? And we do return. And no return type declared. Okay, because we need to return bool, right? Does our CommonFS define that? No, it doesn't define that. We need to define that returns bool. Okay. So that's that. Let's go back here. OSFS, now it's happy. But the question is, will it allow us to compile it? Baseless methods are deprecated. What's wrong? Our CommonFS, we have file exists, provide that, returns bool, and it's a base. So that is good. And therefore, this should be good too. But for some reason, again, it doesn't see it. Maybe after we compile it. Let's do something similar. If fs directory exists, and let's just give it home, xconti, repos, CommonFS. We'll just try to reach it in here, and license, okay. Not directory. If file exists, then we're gonna say echo file exists, and so the file would just say license file, okay. And we just need to remember that this is .path, so we convert the string into the actual path. We have fs, all that, and declare routine. That's very strange. So let's try to build it, run and build it. Okay, that worked. License file does not exist. Really? Oh, S. Save. And run it. License file exists. Perfect. So that's good. Hey, it worked. And we actually didn't get any exceptions. So it looks like the whole file exists, doesn't throw any exceptions. Okay. So now how can we fix our nym suggest so that it can actually figure out that there is something going on? What's gonna happen if I'm gonna go to settings, build on save, and do true? Okay. We save this thing, builds it. It looks like it actually ran it. Seriously? Every time we save it, it's gonna run it, and didn't fix the error. Okay, never mind. Let's set it to false. Looks like our nym suggest will need some improvements to figure out what on earth is going on. Go figure. But hey, we have file exists implemented. We're going fast, so that's a good thing, I guess. So let's see what next. We're just gonna grab that check mark and put it on file exists. Now let's do remove file. So now, or maybe before we do that, let's think about this whole file type, okay? Because now, so, you know, we could have something like create file that we call on the file system itself, and we give it the file name, right? And it creates the file, and let's say it returns us this little file object that should point to it, okay? But when we have something like remove file, we could also have it, hey, file system dot remove the file, so that it has the file system. We provided the file name, and it's gonna remove that file. But we would also like to have that remove file on the file itself, right? So how do we do that? We could have it defined automatically that whenever we call remove or whatever on the file itself, the file itself would store the file system that it's defined on and just call the remove file on it, passing the path. I guess that would be the quickest solution, but I wonder if we can, you know, make it a little bit faster without needing to redo something with the path. But probably not really, because we need to call it something that does something with it anyway. Let's try to implement the file, okay? We start here. We have file system, okay? Let's define it here as well. We're gonna have this file system, and then we would specify file, okay? And that will be public is ref object of root object. And it will contain something like, it will contain a reference to the file system, right? Which is file system, because we need to know, it needs to know what it was defined on. If we have a file, it needs to know itself if it's defined on a OS file system or specific on in memory file system. You know, when we do operations on it, it needs to know what to refer to. Then what else we have about the file? We need a path, right? And that's it. It needs to be the absolute path, okay? Because what can happen is, let me show an example here. Let's say we have something like fs dot set current directory. Okay, we say that we're working on this thing. We do var file is fs.create file, and here we could just say test.txt, right? We're gonna create a file like that. That should return us the file, and when we set test.txt, that means it's a relative path, and therefore it will be this / test.txt. And if we would then set a different working path, I don't know, like var / whatever, and we do file dot, I don't know, write hello world. If we would do something of that sort, the file needs to know that it's pointing to this and that, not var whatever / test.txt. So therefore the file itself needs to store the absolute path. So if we go back here, the file stores the absolute path. Okay. And what else do we need to know of the file? I guess that's it for now, right? We know which file system and a path to it. Let's keep it minimal. We'll expand as we go if we need to. So as we're creating those methods on the file system, let's assume that whatever those are here on the file system itself, we should be able to, these would be like the base thing, the most important thing that will be actually implemented by all the libraries, while for something like a file or maybe a directory, if we're going to make one, we would have just little helpers that can call something. So an example would be, instead of defining it as a method, we would just make a proc, and let's say exists, and it will be self will be file. So we can do file exists, because we don't need to be redundant here with the name file. We'll give it bool, and this doesn't have any basis, and we just do return return. We do self.fs.file exists and self absolute path. That's it. So we grab the file system from the file. We use that file system and call file exists, and we provide the absolute path that was already stored inside the file. Okay? That's it. And we can just copy this whole documentation string. Returns true if the file is specified. If the file exists, if the path points to a directory, it returns false. Okay? That means that if we already have the file, we can just get something. And that also means that we should be able to create a file by providing a path. Okay? I get a file handle or something. So let's say that, let's just make a little section here. And this will be directory operations. And this here will be file operations, okay? So our first operation will be method get file, okay? And we just do, what file system we're doing it on. We need to be able to provide a path, and it will return a file, okay? We shouldn't care about any of that. Returns a file object for the file with a specific path, even if such file does not exist, okay? We just want a handle for that. So let's call it get file handle. Just so we know that it's just a handle, not the file itself. So the result will be a new file where we specify the file system for it and the absolute path. And that's the thing here. We don't want it. We want path dot absolute path. I guess what the absolute path needs to have. How do we call it? Absolute path. Path and the get current directory. Oh, I see. So we might need to do that now. Okay. So let's do self dot get current directory, and we'll just provide it here. Let's do that. Current directory operations. We'll need to have. Let's not make it up to whoever implements it. Let's do something like for now proc get current directory, okay. And it'll be that. It shouldn't raise anything. It's not in the base. It'll be returns the current directory. Let's call it working directory, okay. And we don't raise anything. It will just return self dot current directory. And we'll store it. Okay, file system will have current directory, which will be a path. And current absolute directory, just so that we're explicit that we want it to be absolute. And notice that this is not something that's being exported. This is purely internal, so that whoever needs to get it, they will do it directly through here. Okay. Can we specify this var? No. I guess we can't. But the whole object is a reference, so we should be able to specify it, I presume. We'll see. So to get a current directory, we just return that and returns the current working directory. The working directory is always an absolute path, just so documentation specifies that. It's clear this way. Okay, let's continue. If we have get current directory, we should have set current directory. We specify the thing and specify the path. And here we actually should be able to have something like invalid path. Okay. Let's have it specify something like that. Or I don't know if it's possible. Let's just ignore it, okay? We'll ignore it. We'll worry about it later. Says the current working directory. The working directory is always an absolute path. Whatever. If provided path is relative, it is resolved against the current directory, okay? So self.current absolute directory will be path dot absolute path, and we need to give it a self current absolute directory. Let's keep those to make things readable. Okay, so this should compute the absolute path of the path. Turns the absolute path of path root, which must be absolute. If path is absolute, return it ignoring the root. Exactly. So this will basically ensure that whatever path we give it, it will be turned into the absolute one, and we override the whole thing. So that is awesome. So that's that. And yeah, we have get and set current directory. So if we save it, theoretically, these shouldn't complain anymore. So that's that. Okay. And because we have the get current directory in our implementation of exists, we can do check if file exists, okay? Oh, and on the file, we get the absolute path. So when we were doing the get file handle, which I think should be a proc instead, the one that's, already implemented, we don't need to be able to override it. So just ignore all of that. The result is file system self, and the file to be created needs absolute path, which will be the path absolute self get current directory. There we go. Perfect. And let's not make it get current directory. Let's just make it current directory. Okay. We'll just save it like that, and the current directory will be just like this. And yeah, this way we can write it as if it wasn't some getter or some computation. It will look more like a property, which already looks nicer. We don't have to have this dangling ugly thingy. I like it. So I can get the file handle, and therefore it should be possible to do all those. Perfect. Me like it. So therefore we can call exists, and we can proceed to something like remove. Okay. So this will be that, and this will be, because we have directory operations, file operations. Well, here we'll just have the file object. Well, this here will be FileSystem object. It's ugly, but whatever. Let's actually do it like this. FileSystem current directory operations. Okay. I'm sure it could be split into multiple files, but we'll get there. We'll get there. Don't worry. FileSystem directory operations, FileSystem file operations, and then we can do file operations. So when we have the file system, file operations, let's have the method remove file. Okay. Self file system path. We just have some errors that can happen. Removes the file at a specified path. It does not raise an error. The file does not exist. And that will be to be implemented. Okay. But what we can specify here that already works is proc remove. Okay. It'll be self file. We don't even specify what it raises or whatnot. We don't care. It will be compiler should figure it out for us. Removes the file. It'll be again self file system remove file, and it takes its own absolute path. Beautiful. Awesome. So if that's the case, then that's the case. Okay. Alrighty. So let's implement remove file. Method remove file. Okay. Try remove file. Expected one of. So let's see if we actually, if the documentation has remove file. We just give us the path, and that should be it. If this fails, OS error is erased. This does not fail if the file never existed in the first place. on Windows ignores the read-only attribute. Okay, we don't worry about that. Try remove file. Oh yes, we need to import it. Comma remove file. F-I-L-E. Save. There we go. If it was error, that was supposed to be OS error. Yes, OS error. Cannot delete file. Sure. Simple enough. So, So let's not target the license file. Let's do something similar to the other one. If we'll take the path here, let's call it directory path. And let's just bam, bam, bam. And then here we're gonna create let file path. We have again test directory, test file. Perfect. We'll just do stuff there. And we can literally copy the whole thing, right? If file exists, I would give it the, what do I call it? File path. If the file exists, the file exists. And we do fs remove file. We provided the file path. And we just call echo file deleted. Okay, but if not, we'll just say file does not exist yet, because we'll be doing fancy stuff. Okay, we save it. Can we run it? Yes, file does not exist yet. So let's quickly go about to create it. I feel like soon we'll need to figure out how to actually write tests in NIM to start, testing those things properly, because right now we just kind of mix around the code that switches some files on and off. And that's kind of sucks. That's going to be error prone, especially that we're making more and more and more. So we did remove file. We actually got around and did the whole set current directory, get current directory. So that's done. That's awesome. We'll actually probably need to modify all the ones that we already had, at least for the file, to affect that. For now, we'll just go about create file. Okay. So let's go to our CommonFS. We have our stuff here. So the file. Let's start with create file. Method create file. Okay. And we'll just give it again the same file system and path. That should be enough. We don't care about errors yet. Creates a file. Creates an empty file at a specified path. It does not raise an error if the file already exists. Not sure about that. Let's just see what the NIM standard library shows us that already exists. Because we have remove, we have move, we don't have any create here, okay? So now, how the hell do we create a file? Let's look at the OS files. Okay. No, that's private. Great. Let's go back to here. We have all that, files. There it is, OS. I recall there was something about it here. What do we have here? We can scroll here on the left. Some blah, 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 bunch of stuff. Get up. This admin is hidden. How do you create a file? There are templates for checking if a file exists. We don't care much about that. Do we need to do some weird stuff with writing? Seriously? How do you create an empty file? Okay, let's do the stupid thing and ask Claude. How can I create an empty file in NIM language? Using NIM language. Let's see if we actually get something. Using the open procedure. Okay, you can create an empty file using the open. Here's how to do it. We just say that we're writing it. That's it. Wow, okay. Sure, I guess opening is enough. Let's copy it, and that's from the OS. Really, we had the OS here? Where'd it go? If we go back to our docs, we're in OS. Do we have open defined here? Doesn't seem like. Let's just search it. Open. It's open array, and that. We're in standard OS, and open isn't showing up. I guess that's just problem of Claude in here. So, sure, we'll get back to it. It does not raise an error if the file already exists. Well, that would be true because if the file already existed, the open won't create it. But at the same time, I don't like it because when I'm calling create file, it'll be nice to expect an error that, hey, there's something, we're not just opening it. So we'll get back to that, okay? So let's go to our implementation, the OSFS, and it will be somewhere before the file exists. Method create file, okay? And we do that. Look at that. Try open path W. Huh? So what the hell do we have here? The suggestion here was var file open and then close it, right? So open can raise an unlisted exception, IO error. Okay. And we give file name and FM right. Well, here we have some mismatch, like what the hell is a W? So we take this, we paste it here, and that should make it happy. We just need to defer the closing of it. Defer file.close. So we do that file is this, and defer file.close. Something's not happy here. Oh, we just literally open close. Sure, that works. We don't need anything. Not even, no, we should do defer, okay? Because if this errors, that will never be called, I think. Or no, it shouldn't. Because if that fails, we never got the file in the first place. Okay, that works. Perfect. Save. And this isn't happy. Type mismatch. Why? The open either expects already a file handle or files the string. Seriously, it doesn't expect a path. So we do path.string. And now it's happy. Oh, that's silly. Okay, but what we should always do is, now that, let's make it the first one. Because when we provided path, when we provided a path, we should basically make sure that whatever we're doing here, we're using the, what do you call it? We're considering the current absolute directory, like our working directory. So that means that we'll need to do some more stuff. In theory, all we need to do is something like let absolute path is the path dot absolute, and we just provide it with self as the OS, dot current directory, okay? Because that should be absolute path. And this should combine them if necessary. If the path is already absolute, it will be fine. So all that should be good. It's just, what is the problem here? What? Absolute path is, yeah. Expected one of absolute path. We give it path and the root. Well, you have the path here, which is the path, and current directory should be defined here. Right? Current directory. Unless we do some funky stuff here. No, we have the whole CommonFS. Not sure what's going on. Do I need to do this? That would be even sillier. No. What if I'll do let current directory, okay, is self dot current directory. I should be able to do that. It's error type. Let's ignore it. Let's see if compiler will actually allow that to do. So we have the absolute path, and instead of just doing this, we do this dot string. And that should be it. Okay, for creating a file. And if we have this or that, we just can't create the file. So let's ignore the errors, because NimSuggest is just notorious about making everything, hey, this is an error. So let's do this. If the file does not exist, let's do fs.create file, and we'll give it the file path. Okay. And let's go to the file and create it. Okay. Let's see what happens if we're going to try to compile it. Bam! Invalid indentation. What the heck? What? Why is it invalid indentation? Because this or something? Getting confused. Save. Oh, because there was some white space here. It thought it's the same indentation. Oh, I see. Or not see. Okay, I'm getting confused. Let's try again. Indentation 38.1. And OSFS 38.1. Oh, we didn't close it here. Save. Let's try again. Now, CommonFS template generic instantiation from here. And then we have the OSFS 3026 absolute path. It can raise an unlisted exception. Oh. Unlisted exception. Value error. Oh, it doesn't mean that when we call absolute path, it can basically get some value error. I see. So let's figure that out. What exactly is throwing that? Because it says 26. Which character is 26 here? Path and the dot is 26. Okay, let's put it here. And let's do it here. And then let's do accept value error. Okay. Right now, we'll do that invalid file path. Okay. And let's get back here, redo it. And then we got some errors. Okay. So basically that create file, it tried to call it. Unhandled exception, cannot create file. File system error. Execution of an external program file, okay. So it tried to create it inside the test directory. But unfortunately, at this point, the directory was already existing, got deleted, and then we tried to create it. So now when we run it again, it will try to create a directory, and then it's gonna try to create a file. So let's retry it. Oh, directory created, file created. Let's check. Let's go to ls. We go back twice. We're in the home directory, and we have test directory. ls test directory, okay? We have our test file. Cat test directory test file, okay? It's empty. Perfect. Hey, our file creation worked. That's success. I'm somewhat excited. So if that works, that means there was the possibility of that error here. We should be able to create a new type of error. Let's call it something different. So we don't need that on the side. Let's make it a little bit more readable on the stream, because, you know, I need to have gigantic text so it's easy for everyone to see. So we defined so far the file system error, but let's make another one, something like invalid path error, okay? So it's clear that something with a path is catchable error. Raised if the provided path is invalid. For example, contains forbidden characters, is too long, etc. Okay? That's good. So we can make it so that when we call create file, it can also return invalid path error. It will be allowed to do that. Okay. And therefore, when we go to the implementation of it, if it during this whole time throws the value error, we can just do new exception of invalid path error and invalid path blah blah blah. Let's see if it actually works or if the theory is right. Run it, and worked. It just couldn't create the file because the directory was missing. So in our description of the create file, let's make it just an empty file and specify if the directory in which the file should be created does not exist, it raises an error. Okay. It raises an file system error, okay? It'll be even more specific. The file system error. Double error. Don't like it. Okay. Cool. So that was the first one where we actually utilized this whole get the absolute path and whatnot. I just don't like calling path.absolute path.self current directory blah blah blah. I wonder if we'll just simply make it something like you know, the file system dot I know, something path, and we just give it a path, okay? But first we just did the create file, okay? So let's make it also callable from the file itself. Let's just make it create, okay? Wait, proc create, and we do self file, create an empty file, does not file already exists, and directory blah blah blah. It's the same thing. Create file and oh wait, we cannot create file from the file itself, so what the hell am I doing? Okay, my bad. But I think we forgot about one thing. The create file should return the file itself, okay? Or whatever, file handle or something. So we added that here, and we say if succeeded, it returns file object for the created file. Okay. So here we have the create file. If we tried it, we should do return, and we do, what was it? Self dot file. What was the name? Get file handle, right? And we'll give it the absolute path. Sure. That should be good enough. And we need to say that, hey, we're returning the file. Okay. There we go. Isn't happy about something again, but hey, it usually works that way. So let's try to redo it. Error, ambiguous identifier file. One of the following sync.io file or CommonFS file. Ah, yes. So let's maybe make it less ambiguous, okay? Let's call it file handle or something like that. Oh, sync.io of course has a file handle. Sure, let's keep it file here. Just we're gonna make it CommonFS.file. Okay, and this should be good. We'll try to run it, and we'll complain that this thing here return a file, or we're not doing it with it anything. So we do discard. Okay. Oh, let's do actually that let file. Okay. We get that file reference and file created, and here we can also check if, or more like, let's do echo the created file exists, and we give it this, and the next value will be file.exists. Okay, and that should be it. Yeah, let's try it. Gosh, those errors are driving me nuts because it all works. File created, the file exists, so it called and it worked. It's just a lot of red. Cool, perfect. I'm happy with our progress. Let's just make sure that whenever we have this whole path thing, okay, like here with the create file, right? In create file implementation, we need to make sure that the path provided is that we're gonna convert it to the absolute path, considering that our file system can have some current directory specified. So let's think about naming. How should we call it? Because it would be nice if the the file system provided some kind of proc that I can call. Hey, given that path, give me the proper absolute path, okay? Something like get path to, okay? Get absolute path or get proper path. Oh, it doesn't make sense. Any suggestions? I'll just start writing it because I can do that. It will be in the file system current directory operations, something like proc get absolute path to, right? And we'll do, yeah, we need to give it the file system, write it on the file system, give it that. So returns the absolute path to the provided path. If the provided path is already absolute, it return as is. Exactly. And Just path.absolute path. So exactly the same code. And we just provide it with current directory, and that should be it, I guess. Yeah, I guess that's it. So, gosh, I have a crazy idea of just making it a default. Yeah, I have some ideas. What if whoever needs to implement the CommonFS, they will always already get the proper file path so that they don't need to do any of that. A crazy thought, right? It will require some rework, but I don't think it'll be too much. Okay, let me skip all the explanations. Let me show you what I mean. Let's say that, we leave the whole current directory and get absolute path to that. We need that. But let's say that we get our directory operations. We're going to start reworking those, right? We have the create directory. And that's where we would need to make this whole, we get a path, but we need to ensure that it's, an absolute path and whatnot. So let's do it a little bit differently. First, we define a proc, okay? Create directory. And that will basically do exactly everything, right? It has the comment here that this and that, creates a directory at the specified path, does not raise an error, blah, blah, blah. We get rid of this because this is not a base. We don't specify anything here. It's all fine. But what this will do, instead of raising an error, what it will do is it's gonna do the let absolute path is self dot get absolute path to the path. Okay, we get the absolute path. This is the safe one, and then we just do return, or not even return. We just do self dot create their implementation, and we give it the absolute path. So here will be IMPL as an implementation. We won't make it exported. I hope it's gonna work if it's not exported. And that's our base thing. So instead of path, it will be the absolute path, because that's gonna be safe already. All right, it doesn't need the extra comment here, but it needs to say that it's a base. It needs to still specify what exceptions it's allowed to raise. We'll get to that raising its own kind of exception in a second. Yeah, and therefore, let's check if we can go to our OSFS and fix it. Method create directory, IMPL. We remove the whole export. We don't care about that. And this will be the absolute path. So it's already safe. So we can just quickly do, call create directory, whatnot. It should all work. So let's see if it still works. Save it. We run it. No. Attempting to call undeclared routine create directory implementation. Ay. So that's the CommonFS.nym 43.7. Oh, CommonFS 43. 7. Oh, because it's defined before that. Okay. Let's fix that. Let's do this first and then that. Okay. Let's save it and let's try to run again. Oh, hey, it worked. Let's run again. And now it worked. Okay, so now we just learned something new. Something very important, I believe. So if we have our create directory, it's being exported. But the method that we want to override, it's not exported yet. In a separate module, we're able to override it. Also without exporting. And that's enough for the language to pick up on it. Like, oh, wait, you actually overrode the proper method and the whole thing works. Awesome. I think it works. I mean, it works because it didn't throw an exception that it's not implemented. It just worked. That means we can make the whole thing work safely. Oh, that makes me very happy. So we can do the same check for if directory exists. Oh, wait. So this create directory inherits, basically because it calls this thing in the implementation, it knows that it can raise either this or that error, but the whole absolute path, the get absolute path, we know that when we call the path.absolute path, this thing can throw an error, it can throw an exception of value error or something. We already needed to handle it, I believe, down here when we were doing create file. See? If it's a value error, throw that exception. So just to keep things in a nice way so that, you know, it's a value error or whatever, let's keep it as invalid path error, something a little bit more decent. Let's just copy that. And our CommonFS, when we define the whole get absolute path to, we can basically have the whole except, like this, and we do try. Okay. Save. So basically when we do that, we handle the value error, and we should do that. And let's just make sure that this thing has this, whatever you call it, this clause or whatever. It was called something. And let's make sure that it can do raise or raises. It raises. And we just give it a single one, which will be invalid path error. That's the only error that it can throw or whatever. We save it, and what's the problem? Oh, IN, not IM. Okay, perfect. That will make it that even though we don't have that error defined in here, we call it here, so this create directory will know that, okay, on top of this and that, I'm throwing that other thing into the mix. Okay, should be good enough. So let's continue with this. We have directory exists. That stays the same, right? But we basically make a similar one. We do proc. Oh, let's do this impl implementation. Proc direction exists. And this will be the exported one. This one, the previous one shouldn't be. And we do the whole thing the same. It's just gonna be self FileSystem, comma, absolute path, bam, same comment, so that we can remove it from here. And no, we don't do that. We do let absolute path, and then we do return this thing. Okay. So now that we have two instances of that, let's just go to the implementation of it. There exists IMPL as an implementation, and that should be all that we need. Let's go back here. So now that here we have this and the new version of it, for this we already have a new version of it. So if we do IMPL here, okay, we can do just this. This should already start proc, remove it. Let's just make correct, not path, absolute path. Oh wait, I'm being a dumb one here. This should be a path. The AI is okay, I'm wrong. So there exists should be path, normal path, because that's the public thing that we're exporting, right? That's what everyone will see. While absolute path should be on this internal implementation. Therefore, when we go to here, this should have absolute path everywhere. Okay, now we're good. So now remove directory, we got this, should suggest the whole thing here. There we go. Wow, we don't have to write code. Okay. And again, in OSFS, all we need to do is not make it exported at IMPL. And instead of path, we just have absolute path. There we go. So that's that. What else do we have? That's done. Let's go to get file handle. Get file handle. Yeah, the same thing should happen here. We should be able to get the absolute path. But hey, this is already defined here in CommonFS, so we don't care. So let's do here, let absolute path. Okay, we get it normal way. Instead of defining it here, we just do this. Okay, a little bit cleaner. We have it as a separate step, reusing the functionality from the thing itself, so we don't have, you know, different code. And therefore, this get file handle suddenly will return also, it will raise proper exception if that path was invalid. All right. So we have only 3 more methods. Our create file. So we again do create file IMPL implementation. We go down here and we'll do proc create file, blah, blah, blah. It's all good. Now it should suggest exactly the same command, get the absolute path and pass it on to the implementation, where implementation should have absolute path instead of path, blah, blah, blah. So that's good. And we can actually get rid of invalid path error here because we're already converting the whole thing here, right? So this will throw its own thing. Therefore, when we go to the implementation of it, create file, we make sure that it takes absolute path. We don't need this anymore. We just do open absolute path.string, close, and whatnot. We don't worry about any value errors anymore. We have the whole thing a little bit simpler. Oh, get file handle can also throw this whole thing. Oh well, invalid file path. Huh, so we just get the handle here. Oh, at the end, of course. This actually should never happen because we already verified it. So let's make it more descriptive here. Couldn't create file handle due to invalid path. Just when debugging, we have a little bit more info here. Okay, so that's great. And we have only 2 left here. Okay, that we need to convert to this new way of calling it. Of course, let's remove all the documentation stuff here. That's good. Very good, actually. And let's correct the file exists. So file exists impl for implementation. Okay. And we can just do the proc file exists with everything good here. It should suggest the whole thing. Again, we get absolute path here and call the implementation. So the implementation, we replace path with absolute path, remove the comment, and go to the actual implementation. And let's do, wait, create file impl. See, we're already losing some things. File exists impl, and it takes absolute path, and we provide it here. That should work. So while we're here, we can also do remove file. Will be impl because we're overriding the implementation of it instead. We'll just do all this, and in CommonFS and the interface, we again remove file, turns into impl, and AI will suggest everything properly for us. I'm not even double checking. Yep, I'm just skimming through it. It looks like proper code. Yes, yes. And this is the only thing that actually needs to get replaced. Absolute path. Okay. Okay. There we go. So, basically, because we replace, our interface, CommonFS, because what we did is that the library that will be implementing that interface will be asked only to implement those impl variants, right? Those actual implementations. And we wrapped those, we added the exported procs that literally already make sure that whatever path was given to the proc, it automatically turns into absolute path. Suddenly, whoever implements the interface doesn't have to worry about it. So, the file system implementations will be just a little bit less error prone, right? Because if you're implementing a library that uses that interface, suddenly you're relieved totally of worrying about, oh, I'm working some current directory. Suddenly I need to be really careful with paths and whatnot. Well, here, if you're getting the absolute path every time you're doing something, that should fix your problem, right? If you're implementing something for some weird library, at least you have that consistency that every time you get a call, you work with absolute paths, so you do your transformations or whatnot somewhere else. So this is, I'd say it's really nice. I really enjoy that approach. Makes it a little bit safer. So let's just make sure that our code still works. Okay. Let's try to compile it. Error type mismatch, of course. Oh, in CommonFS NIM57, that's in our directory exists. Oh, what's going on here? Absolute path. Oh, because it doesn't have the absolute path. It has path. Huh. Okay, and this is the file. This is this, that. Okay. Let's go back. Let's try to rerun it. Another error. Couldn't create file due to invalid path. What? Hey, that's new. Okay, so we basically called the whole thing, right? It tried to create the file. It took the file path. Therefore, create file, okay? It went to create file. It correctly got the absolute path because the get absolute path 2 returns error and file path. Okay, just that short. But we didn't get that here. It actually went down to create file implementation. And in there, create file implementation, it opened it and closed it. And then it decided that the get file handle is suddenly where I'm gonna crash. What the hell? Okay, so let's figure out, to fix that, we would need to either go debugging, but I think we should learn something else. Because right now, whenever we're raising the errors, we're just creating a completely new error and a completely new message. We're losing what the actual problem was in the first place. So in our try except, what do I call it? Construct. You know, somewhere else will be try catch. Here we'll have try except. We catch the error, but we don't get the error value. So let's look up how to actually handle that, okay? Because we should be able to capture the error, right? Let's go to nimdocs and let's, again, let's duplicate it. I like to take it as a little template. So nimdocs, wasn't it tutorial part 1 or something? Statement, blah, blah, blah. Because I saw it somewhere, I think. Procedures, blah, blah, advanced types. Nope, not here. Tutorial part 2. Do we have error handling? Exceptions, there we go. Raise statement. Don't care about it. Try statement. Handles exceptions, so we do try, except. The empty except part is executed if there is an exception that is not explicitly listed. Okay. There's finally part. If you need to access the actual exception object or message inside the except branch, you can use the get current exception and get current exception message procs from the system module. That's different. Okay. So we just do E as get current exception and message, get current exception message. And they even show that you could do echo, got exception, something, representation of it with message, and then the message. Okay, let's copy it and see what we can do with it. It kind of is ugly as heck, but hey, let's just start with that. So we do let E is that exception, message is the message. So instead of the echo, we of course raise the new exception and couldn't create file handle due to invalid path. Let's do semicolon. And we add the message or like colon here, and then we add the colon, space, and representation of the error. Ugh, it's so ugly. But hey, that's what we're working with. Maybe later we're gonna learn how to do it a little bit more gracefully. So let's save it. What's the problem here? Val, huh? Let's try to compile it and see what happens. Bam. Couldn't create error. Wait, what? It's just unhappy that there was an error when printing the error? What is going on? Let's do the damn echo like it was there. Echo. There you go. We're going to crash this time. Save it. Oh, you can't raise it here. Whatever, let's run it. Because I'm getting confused. Nothing got echoed. $38.5. $38.5 in OSFS. I guess it can't compile it or something? Oh, it can raise an unlisted exception. That's what it's complaining about now. Okay. I just need to do the create file implementation. Create file implementation, comma, invalid path error, right? That means this whole time, this was a compilation error, not the execution error. Oh, I am so dumb. Just lost 15 minutes figuring it out. At least we know how to capture errors, right? Okay, this is thing, cannot create file. The next time we run it, create a file and it checked and it exists. So we know that the other errors can happen, right? How could I make it so that it actually prints them? So yeah, all that. So what if I'm gonna do that everywhere? We have the error. Let's just shove the same thing here and we just attach that thing. And we do bam. We'll do the same thing here where we extract both error and the message. And we know that the next execution of our program should throw an exception because we delete the directory before we create a file, and it shouldn't be able to do that. Here. Wow, okay, it printed out a lot more. Error, unhandled exception, cannot create file. And it shows cannot open the path. Okay, we have our semicolon, and we have the whole exception printed here. Just this, the parent name, the messages in here. We have the whole trace and everything. So I don't think we need to worry about that because if we haven't handled this error, I wonder if we can just pass the previous error when like, you know, I recall that when you're creating a new exception, it would be nice to be able to specify the parent of an exception, right? Because sometimes you need to, you know, rewrap the whole thing. So let's see if we can do that. We call new exception. Oh, you can specify the exception, right? The type of it, give it a message, and then you can specify the parent exception. Awesome. So what if I'm gonna just do that? We don't even add this whole representation of the exception, whatever. We just do comma, representation error. I mean, not representation, just straight up E as an error. Okay. That's happy now. Let's do the same thing with this one here. Bam. And this one here. Bam. So let's run our application. First one is good. Second one, error. Unhandled exception, cannot create file, cannot open, blah. File system error. It shows at the end that the type was file system error. Okay. And in theory, whatever is handling it could get to the parent, figure things out, and we're all good. Okay. That's good with me. I don't mind it. That's a little bit cleaner. Does it mean that we want to include that message here or not? maybe we could actually straight up just print the message, okay? Because in our case, in the case of OSFS, when we, it's not like we're writing our own implementation from scratch. Like when we'll be creating finally the implementation of the interface for in-memory file system, which is the whole goal of this making this library, that we can have the same interface for interacting with real file system and in-memory file system, then we'll be able to provide a bit more info when an exception happened. But in this case, we're relying on some other implementation. In this case, on a open or close or something else would have already built in remove directory. So if we just say, oh, we cannot delete directory because we tried to delete it, right? As an exception, like error message for the function remove directory, that's kind of like pointless. So it would make more sense if we were able to just reuse the message that was given us from the actual error. So continue with this create file implementation. So here it makes sense because we know that couldn't create file handle due to invalid path. That kind of makes sense because we know that this should never happen. It's our weird little exception, and whatever will be in here will be wrong. Like, it's just an additional info. So I would save this one the way it is, keep it. You know what? Why do we even have this here? Because can we just do e.msg, right? That'll be the same thing. So let's save ourselves some lines and just do this, okay? It's going to be a little bit nicer. e.smg, msg. But when we have OS error, we really don't know what the reason for it is, okay? So instead of, cannot create file, like generic thing, let's just have this whole, just reprint the message that the other error gave us. And we provide an error for, the parent. And the same thing can happen for IO error because we don't really know the reason for it. We just know that something went wrong. And bam. This way we should provide a little bit nicer exception, error messages. And let's also keep the whole, so far we noticed that the errors or exceptions or whatever you call them that are being thrown by the by NIM standard library, they all start with lowercase letters. So let's fix that, okay? This cannot delete file. Let me actually go through the whole thing and fix those little errors. I know it's a little bit tedious, but let's fix it before it grows into something larger. We know that both of those will need to do that this will need to do that. We took care of this one, and we have one more here. Well, it's not that much work, okay? So we'll have eMessage. So here, instead of cannot create directory, we're actually going to provide the whole message and throw in the error as well. And the same thing here. Again, random cannot delete directory. Let's skip that. And same thing here. So much better. So much better. It's kind of stupid though, because the get current exception, even within that branch here, will just give us generic thing. Isn't there a better way to handle those errors, really? Where is it? Here. It shows that we need to do this whole gymnastics. That's kind of ew. Because I don't like it. I would rather have it here that I can specify the error. Let's just double make sure that this isn't like the only way to do things. Because maybe if we look into, come on, separate all tabs. If we'll look into language manual, I recall that somewhere is something like the chapter about error handling, right? There must be. Exception handling. Accept clauses. Look at that. Accept IO error as E. Alternatively, it's possible to use the get alternatively. Why is the tutorial giving us this, if you excuse me, shitty way of handling error where we can just do that? Like, seriously? And if you do that, you will need to cast the whole thing. Oh, jeez. Let's just use this. This is gonna be way nicer instead of stupid lets and whatnot. Just do that. Bam. And suddenly E should be of type, of proper type. There we go. Same thing here. Let's just do like that. So we can select from here to here. Bam. From here to here. Bam. And the same thing here. Oh, so much better. I really like when the code is short and easy to read rather than bunch of unnecessary bullshit. There we go. Finally something readable. And we can get rid of those here and here. That's how it's supposed to be. Okay. All right, now I feel okay. So when we had this whole thing where we raised that exception, yeah, here we have the get absolute path too. Okay. And when we had the value error as E, we throw a new exception, invalid path error, and let's do invalid file path. No, it's not even a file path because this doesn't care if it's a file or not. Let's just give it the whole thing. E.message and E. There we go. We should get something, you know, that has more meaning because already invalid path error suggests that it's a error of a path. So why repeat it in a message? Okay, there we go. But now I realize that when we call set current directory, we also set this whole thing. Use this whole, you know, absolute path. And that means this can throw the exception as well. Therefore, we should have this whole try catch here as well. So let's do it. Try and then accept. We can just do the whole thing exactly the same way. If our path isn't valid, we'll throw that error. And we're not gonna deal with, you know, some random value error or something. This is specifically from this, what do you call it? CommonFS. It's about that. We'll have explicit errors here. Okay. Okay. I'm starting to feel better. Good, good, good. So let's try to run it. Okay, that worked. And if it's gonna error out, we have unhandled exception cannot open. And there's that. And oh, it didn't tell us that what type of error that is, but okay. Sure, there you go. So yeah, it was cannot open and something said unhandled exception and gave that. Maybe we should prefix those things. Nah, because those errors shouldn't be shown to anybody in the first place, okay? Let's just leave it the way it is. Okay. And something tells me this unhandled exception is exactly from here when we call it. And because an error is being thrown, our code adds that. It's not from somewhere within or whatever. So we're good. We're good. What are all those? Nim. History restore. What the heck? Go away. Go away. We left with just bash. Where is all good. Okay. All right. So let's move forward a little bit and check our status of those things. We have file exists, we have create file, we have all those fancy things. Wow, so we basically have basic directory stuff, basic file stuff. We just would need to be able to get file info, which is a little bit more work, I guess. Open file, not sure what for. Yeah, oh, we had this open file and that returns a file. We already did the whole, what do you call it? Get file handle. Okay, that's a little bit more descriptive because it means that we're not actually touching anything on the file system. Okay. And this way we're good. And we create a file. Do we really want to return a file? I guess when we're creating it, it wouldn't hurt, right? But when we're doing other operations, like write to it or whatever, we won't be bothered by returning a file. We'll be just, whatever was number of something or whatever. Just the create file will be this specific instance where, oh, by the way, here's a file if you want to have a handle to it, because we just created it. So that's good. That's good enough. Read all, read bytes and whatnot. That's good. But we need to start making sure that the code we wrote is actually doing the proper thing. Okay? Because right now we don't know. We just have a little test that tests a few things. It doesn't test if when we're using our whole what do you call it? Set current directory, get current directory, all that. It doesn't really test that properly. So let's figure out how to write tests in NIM. Because that's something that none of the tutorials touched on. I'll be surprised if the language manual would say something about that, because when you with Go language, it's all built in, but I wouldn't expect NIM to be like Go and like, oh, we have built-in constructs for testing. That's part of the language itself. We have all that. Modules. We'll need to learn more about modules as well. Blah, blah, blah. Macros, templates, generics, effect system, exception hand, types, sections, converters, iterators, methods, procedures, statements. No, this is all basic stuff already. We'll go to NimDocs again. Let's duplicate it like a 5th time. Macro tutorial. Standard language tools documentation. Let's see what tools are here. Atlas, a simple package cloner tool. It manages an isolated workspace that contains projects and dependencies. I'll open a new tab because that might be good to look at. Held code reloading. Documentation generator, that would be nice, NimDoc, because that's where we're writing those little fancy comments that I think work as a documentation. Nim suggests, C2Nim, no, Nim inst, generate installer, nope. Grep, pretty. Testament is an advanced automatic unit test runner for NIM tests. is used for the development of NIM itself, offers process isolation for your tests, it can generate statistics about test cases, supports multiple targets as C, JavaScript, etc., has logging, can generate HTML reports, skip tests from a file, and more, so can be useful to run your tests, even the most complex ones. That's it. Alrighty. Test files location. By default, Testament looks for test files on in the folder tests. Then we have category and NIM, whatever NIM files. Okay, you can override this pattern by using the pattern glob. The default working directory path can be changed using OK, and we have directory that. So this is basically the, I guess when you're calling the tool from command line. Testament uses nim compiler on path. You can change it again, blah, blah, blah. We don't care. We're using the one from path. Commands. So run all the tests matching the given pattern. All that. We'll get to that. So options, print, blah, blah, blah. Running a single test. Yeah, you create the directory and you write assert this and that to the nim file. Wow, that is really simple. And Testament run this specific file. Okay. It passes, or you can do file nim in there. Okay. Okay. So you just write a bunch of asserts and it just runs the file and that's it. Must be. Running all tests from a directory, just give it, pattern and then whatever, nim or something. Okay. Oh, and you will need to test for 2 levels deeper, whatever. Can you just say find everything? HTML reports, writing a unit test. Okay, example template to edit and write testament unit tests. Okay, so it's just one gigantic comment. So what do they suggest? They suggest that what actions to expect completion on. Options, compile, expect successful compilation, run expects execution, or reject expects failed compilation. Errors and fatal pragmas. So action is run. Okay. Oh, I see. So you can have tests that specify that the action is to run it or compile it, or even expect their failed compilation so that they can make sure that if somebody tries this specific thing, it won't compile. Hey, that's interesting. Gosh, that is actually powerful. I don't know if I've found anything like that anywhere else where you can say, hey, this shouldn't compile. So you can make sure that somebody doesn't override something or do weird stuff. Like, hey, don't use this specific macro. And no, because then, okay, so expect fail compilation. The reject action can catch error pragmas, but not fatal pragmas, because fatal pragmas guarantee that compilation will be aborted. Oh, okay. But whatever. But basically, you can say that whatever's in this file, it should fail to compile. So if somebody expect failed compilation. So no, it's not like, oh, if this compiles, be upset about it, is the other way around. No, wait a moment. Compile expects successful compilation, but reject expects failed compilation. Okay, so if basically you can give an example of something that should fail, and that's it. Okay. So then we have the exit code. The test is expected to return. Typically the default value is 0. Know that it's okay. We don't care. It'll be run by Valgrind. Valgrind. I heard that name somewhere. Provide an output string to assert that the test prints to standard out exactly the expected string. Oh, okay, that's how you can check it. That's fancy. So whenever you echo or whatever, you can make sure that the output is nothing, that it didn't echo anything. Okay. Wrote an output substring to assert that the string given here is a substring of the standard output. Okay. So that part, like, it includes that in there. Okay. Then we have sort output, whether to sort the output lines before comparing them. Okay. Each line in a string given. Oh, that's interesting. Sort output. So basically, I guess you can write a test that returns a bunch of lines into the output, and you can actually sort them to compare it. So let's say you wrote an algorithm that is supposed to I know, take some data, analyze it, and spit out, you know, possible values, let's say, right? Things that it found. But it really doesn't matter if what order it's spit out, as long as it's good. You don't need to write suddenly some kind of comparison thing that will make sure that everything matches and sorts it and whatever. You can just straight up echo it into the standard output, and then select and say, hey, I expect those values, literally a string, and just ask it to sort output for you, so that wow, that's so that, you know, when it compares to whatever you wanted in a sorted form. So that's funny. It's like kind of hack, but should save stuff. It's like, you know, so simple that it seems dumb, but at the same time, its simplicity can save you so much time, because, oh, I don't need to add something to a list. I don't need to maintain this array or a sequence or what. You just echo it and that's it. You're done. You don't have, you know, one less thing where you could make a mistake. And because of that, your test could be, you know, wrong. Then each line in the string given here appears in the same order in the compiler output, but there may be more lines that appear before, after, or in between them. Nym out, a very long multi-line string. Each line in the string given here appears in the same order in the compiler output, but there may be more lines that appear before, after, or in between them. So I guess you can say that in nym output you're expecting, oh, this is a compiler. Okay, in a compiler you expect that at some point there will be a line with a very long comma. Then could be some more lines until it will be multi-line, and there could be more lines until there's string. Interesting. And then this is the standard input the test should take, if any. Oh, so you could do read line and bam. Huh. Error message the test should print, if any. There you go. And can be run in batch mode or not. Okay, is it batchable? In our case, we'll be doing file operations, so this will be false. Can be run joined with other tests to run all together or not? What's the difference between those then? Can be joined with other tests. I am not sure. So on Linux 64-bit machines, whether to use Valgrind to check bad memory access, memory leaks, and whatever. So can you use Valgrind to check out memory leaks? Hell yeah, go for it. But I guess this is only for Linux. Okay, I don't care. Whatever I'm doing is on Linux, because Windows is, I know, kind of broken. Command the test should use to run. If left out, an empty string is provided. The command is taken to be nym, and the target, hints on, testing, and the path to nimble and whatnot. Okay. All right. Then we have maximum generated temporary intermediate code file size for the test. Huh? Max code size is 666, whatever. Maximum generated temporary intermediate code file size for the test. Not sure what is the intermediate code file size. I guess it makes sure that the code that you're testing doesn't get out of hand, as in, because, for example, when we're using the inline iterators, they are, placed in line automatically. Therefore, if you have lots of loops with the whole thing being in line nonstop and it gets longer and longer and longer and longer, or probably in many other places where stuff is inlined, your code size will just keep getting larger and larger and larger. So I guess you could make sure that your code isn't too large, but it says at the same time temporary intermediate code. So I don't know. This needs more documentation. Timeout seconds to run the test. Okay. Targets to run the test into. Okay, which targets? C, CPP, Object-C, and JavaScript. Defaults to C. In my case, here it will be probably just C. Flags with which to run the test. Okay, so I guess you could have a matrix and provide it with few flags. Okay, this and that. Delimited by the thing. So I guess first one here will be without flags. Then you have flags release. And then you have this combination of flags. Okay, that's nice. We can check if all those, because as far as I understand, when we provide this D thing, this whatever definition or whatever, I guess we can read them with those when statements to kind of alter compilation, so that we could, let's say you're making a game, you could have some of the extra features of the game just hidden behind the when, and you could compile two versions of the game, one with extra features, one without, like, oh, this is the developer test, so all the extra functionality that's specifically for development of the game and debugging and testing it, fancy things like that let's say would be allowed only for the testers to use and shouldn't go to the public, could be hidden behind that. Or I don't know, some premium features or whatever. I really like that. This is suddenly turning your tests, your test runner into something that resembles more of GitHub Actions, where you can, provide those variants, do all those extra things. I really like it. Conditions that will skip this test. Use of multiple disabled clauses is permitted. Okay. So disabled BSD can disable OSs. Okay. Like Windows and 32-bit architecture or pipeline runners or disabled true or just disabled. Conditions. Okay. What does it mean, conditions? How do you specify your own? That's my question. So you define all those things, and at the end you can just run a bunch of asserts, whatever the accent is here. But can you run just normal code as well? Because you get a bunch of those random words here. Should they be only in a comment? Example, terminate to edit and write test on the unit tests. Because this is all commented out, kind of. Well, this is not. So I guess inside that comment, this discard thing, we find those things. The test runner just finds the whole comment and just does things. As you can see, the spec is just a discard this. Okay, so it's important to have that as a comment. Spec has sane defaults, so you don't need to provide them all, and simply assert will work just fine. This is not the full spec of Testament. Oh, there's more! Woo! I won't read it now because that will be really boring on the stream. And nim itself uses testament, so there are plenty of test examples. So we'll look at those quickly. Has some built-in CI compatibility, like Azure pipelines. Yeah, we saw that we can disable the Azure, for example. Inline hints, warning and errors, testing the line, column, kind, a message of hints. Warning and errors can be written inline, like so. Warning, and there's warning. So, okay. The opening marks the message line, marks the message column. Okay. Oh, it will just show that, hey, there's a warning. Whatever. Inline message can be combined with nim out. I guess the compilation would be, we can make sure that we can check for compilation errors. Multiple messages for a line can be checked by downloading messages. Matrix. Error max 0, stall check error. I'll ignore all that. Output message, variable interpolation, whatever, command. We're not doing all those things. Okay, we have some examples here, like discard, and we have error message should be undeclared identifier not defined. And we just assert that it should be not defined, or not defined is not defined. Okay, so, okay. Not defined. Okay, whatever. Yeah, we just make sure. Non-zero exit code. So we expect exit code 1, quit non-zero exit code, and we give it 1. And it should complete because the exit code is 1. Okay, well, this should show an error message. And I guess that's it. Okay. Standard output checking. So we say that output should be 0, 1, 2, 3, 4, 5. And we just echo it. JavaScript tests. Target is JS. When defined, JS import standard JS console and console log. That's kind of cool. Compile time tests. So yeah, make sure it compiles. And we do the static compilation of this and that. That's awesome. And tests without a spec completely. You just run the test and it should default to C and all that. Okay, this is extra fun. So let me write down the questions that I have just by skimming this spec here. Because my questions are, because the thing is that we're testing file operations. And therefore, I guess we'll just create some temporary directory where we can run the test. And then the test deletes the directory and is done, okay? But the thing is that suddenly we need to make sure that no two tests are running at the same time, because then it's like, you know, things will be colliding. So let's look at that. What is batchable? Batchable. That will be first thing to check. Then what is joinable? Because, you know, again, the description is like not really, at least doesn't convince me right now. And that was it. What is max code size? And what the default is. Max code size, okay? And I think that's it. That's all we need to know. So what are the other things that we opened up? The specs for the thing, right? Wait, that's the spec? Wait, what? Parse spec, and I'm expected to go through this. Colon, output, file, line. What? Batchable. Result unbatchable is not parse config. Are you serious? Like this comment. Windows lacks Valgrind, still EOS. Okay. And Valgrind only supports OS X less than or less or equal to 17. So I guess later macOSs also don't support Valgrind. That's interesting. So what is batchable and joinable? Come on. Nim out full. Ay, this is not very descriptive. Do we have descriptions up here or something? Nope. Nothing. Nothing. Let's search for batchable. We just have that thing and that's it. Unbatchable. Whether this test can be batchable via nim test and unbatch. Only very few tests are not batchable. The ones that are not could be turned batchable. Okay, that doesn't define what batchable is. And what about joinable? That's probably not defined either. Of course it's not. Make sure is joinable spec takes into account each field here. I guess this whole joinable is that. Oh, I see. So this little comment here means is joinable spec. That means that it can basically combine different tests that have the same spec and I guess not reanalyze spec or do something. Well, batchable, I really don't know what batchable is supposed to be. Oh yeah, there you go for the spec, right? Let me go to Discord and just make sure I have things right. Because we can always ask a question, right? I'm gonna go to nim Discord. Go to the main. Okay. Let's make it a little bit larger. Should we do it main or into tooling? I think this will be into tooling because this is tooling, right? I have a question about the Testament test runner. I can't find the spec. I mean the proper description of what joinable and batchable mean in the test spec. I will be writing a bunch of tests that involve file operations, period. Therefore, I need to make sure that they only execute one by one and never two, like any two at the same time. So that's the thing. Let's ask that question and we'll see, what what answer we're gonna get, if we're gonna get any soon in the first place, right? So that's that. In the meantime, you know, let's not look at that spec anymore. Let's just check some example of a test. Just quickly, I don't know, alias or whatever, t alias. So what do we have here? We don't have any spec in the first place. Test the alias analysis. So we can just write normal nim code, okay? We can define types and this and that. When not, blah, 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 blah. And run code, whatnot. And I guess this is expecting to properly run and properly compile, right? That's it. I guess we don't even need to assert anything. Assert is just to make sure that the value is right or not. Hey, I'm digging it. So let's get back to our quick tools guide, right? Not this thing. Where's the... There we go. We had that whole thing. Output method interpolation, blah, blah, blah. So all we needed to do is create some test files, right? So it's test category nim. So let's look at that. And let me just update the message on the stream. Let's do writing a bunch of tests. Sure, there we go. We have a new message, and I don't know if anybody reads it, but hey, we have a message of what we're doing. Okay. There we go. So we go here. We have our code everywhere. So we could just create a new directory. Bam, tests. And inside that directory, we should have some kind of category. Wait a moment, this goes away because I'm not seeing anything. Okay, so what kind of category we would make? New folder. Let's do directories. Okay, these will be our tests for directories. And if we look at CommonFS, let's do one file per one test file per, you know, some kind of thing here. So in test directories, okay, we're gonna create a new file. Current directory tests.nim. Okay. Oh, that's what it inserted. Okay. Now I know what the settings do when it comes to a few things. Okay, whatever. Guess I'll need to add that everywhere. Ugh. Okay. So how can we test it? So that means that I need to import the CommonFS, right? And oh, okay. I see. So I'll need to write two different kinds of tests. First tests will be just for the CommonFS that has absolutely no implementation, right? What I will have to do is basically create a little temporary implementation of it, and that basically implements, provides all implementations of all the, whenever this needs to be implemented, and the other thing needs to be implemented, and basically tests that the paths are provided properly, that is actually being called, that maybe returns some kind of file, and this and that and that. And then basically I'll be able to write a few tests that check if the whole thing compiles, right? So that'll be one thing. And then inside, I'll need to make separate tests for the actual OSFS implementation. I see. For now, let's work with what we already have, which is the OSFS, because that feels a bit more important than testing the other stuff right now. So current directory test, let's do import that's from, and this will be, we're in directories, we do dot dot, we're inside tests, dot dot slash OSFS slash OSFS. Okay, so that's the file, import OSFS. Or let's just comma create directory. Okay, unless we can't. Oh, I see. From OSFS we just import this thing, but we also need to go and grab the from, what is it, a CommonFS. We need to be able to import the file system and the create directory, because that's when it's defined. Just there, the proc. The OSFS doesn't even define that. So given that, we should be able to. Wow, where did that come from? I guess this assumes it's Python. We have def and those underscores in it, the weird Python stuff. Go away. Good guess, from somewhere import this. That's definitely Python. It's way better than what JavaScript has, where you need to say import what from where, so you're just writing things backwards. Okay. So we need to create the file system, right? So var, let's just let fs is new OSFS. Okay. We have a new file system. Why does it return OSFS? What the hell? Oh no. That sucks, because that means we also need to import the new. When we save it, we have file system. Oh, I don't like that. This whole new thing and whatever. Because that means somebody needs to remember to import the whole new thing. I don't like it. That suggestion that somebody gave me, I don't like it. Let's fix that, because it just, ew, grosses me out. So this whole thing where we overrode new, I don't mind leaving it there, okay? But I want proc new OSFS. That returns the file system, and that returns, utilizes this whole new thing. I'm fine with that. But this way, what I can do, no, let's just get rid of this whole thing. There we go. We don't need to make OSFS available at all. It's just all hidden away, okay? Perfect. We're not even exporting the OSFS. Whoever is using it can't even import it. We just have new OSFS. There we go. So, for some reason, not using that made me uneasy. So now we just import the new OSFS. File system is new OSFS. Okay. There we go. Save. Something's unhappy. Proc new OSFS. So yeah, that's good. That's good. That's good. Okay. Let's just fix that here, because should be like this. Okay. Sure doesn't exist. So we have that, the new OSFS, and on that, can I just run it? What's gonna happen if I'm gonna run it? Okay, that'll work. Okay, cool. Sure. No problem. So we have new file system. Now we need to try to do the create directory or whatever, test directory .path or something, right? And from that, we should be able to test if the directory actually exists, right? So first we would need to do, before we even start this whole thing, is something like initialize or whatever, setup. Then we will have the whole act, whatever, and then we can do the whole, what is it? Assert, right? Something like that people usually use. So, Mitchell Cosworth said, hello. Hello to you too. I don't know if you... No, you're still watching. Okay, hello. It's nice to have a recurring recurring participants. Okay, so in our setup, we need to do a few things, and these would be, I guess, things that repeat a lot. So basically, create a new directory for testing, okay? Where test directories will be placed, okay? This unfortunately will need to, because this is actually testing the operating file system, those tests will actually need to run on the file system. Kind of sucks, but we can't get around it. Then we'll have, we create a new directory, and I guess that's it. Assert will be check if directory was created, and then will be clean up, remove the test directory and all its contents. Okay. I guess this will be relatively easy. We'll be able to use the same things that we used inside our implementation of OSFS. Like when we create a directory, we can just do that. Hey, there we go. And this will be the standard directories, whatever. So let's do that. Let's just import the whole thing. Okay, we don't care what's in there, it's just a test. So create a new directory where the test directories will be placed. Where do we place it? We could just place it here and call it a day, right? So let test directory path, and we'll just make it wherever we are right now, test directories, and let's call it current dir test and a path. That will be our testing directory. Oh, and we need to import the paths, right? Import standard path. There we go. So we do create directory and we call test directory path. Okay. And if that throws an exception, that means our test failed to run. Okay. So that's that. Let's actually do echo. We'll do a test setup. Okay. No, we don't need to, because this should provide us with where the test failed in the first place, right? So we don't care. So we've got that. Then when we act, we'll do stuff, but let's get ready for the cleanup first. Remove the directory and all its contents. So do we have remove somewhere? Implemented? Remove directory. Remove directory. What it does? Removes the directory, including all subdirectories and files in it recursively. Perfect. Just remove directory and erases everything. Love it. Remove directory and it'll be the test directory path. And that's it, right? Does it have any other check directory? Check if it exists first. No, false. We don't want to check, just remove the hell out of it. Okay. So we have that and cleanup, so we can do the act. We create a file system, right? We create the directory, okay, and well, we should test it in two different ways, the directory creation. We should test one where we specify the whole path properly, and the other one where we don't have the absolute path. But that means that we need to have the absolute path. Ugh. Okay. Let's learn more. I don't like this stage of learning the language where you need to look up everything to just because you don't know anything yet. Where were we in documentation? You were in standard OS. Then we have something like the IRS or something. App directories. Helper for determining special directories used by apps. Get cache directory. Data directory. Is there like current directory or something? No, I guess that's maybe that was in the OS after all. App directories, blah blah blah. Maybe it is here OS. Set permissions. Current compiler, creation time, file info. Where is it? I remember seeing something like the current directory where we could get the actual current directory stuff. Maybe it was something like sync or sync IO, various synchronized IO operations. Maybe in here. Close, end of file, blah blah blah. Get file size, get OS file handle. Nope. Not sure. Current. Can we search for current position? Get file position and read all. So that's not it. Is there a way to search like current? And the search doesn't do anything? I guess it does not. Come on, F5 to refresh, I presume. Current. I guess search doesn't work. Ay, ay, ay. I don't like when that happens. System. Maybe in here. Current exception. Current source path. No, that's not here. Atomic speed ups, blah, 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 blah. That wasn't anywhere here. So we're back to the generic. Where is it? Where was it? Generic operating system. It wasn't app directories. Was it maybe in directories? Where did it open now? Here. There exists, blah, 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 remove, set current directory. Okay. How do you get current directory? Get current directory. Get current directory is a standard paths for some reason. Where'd it go now? EFG, get current directory. Okay, and some paths. Returns the current working directory, as in where the build binary is run. Okay. So the path returned by this proc is determined at runtime. Okay. So that will be it. Get current directory. There we go. So let's do it that way, where we go here. And our test directory path, okay, will be get current directory / we concatenate it with this thing. It should work, because get current directory, I mean, when you run it, yeah, now it works, okay. So this should get us the absolute path for it, right? So we can reuse that to create the actual file. So let's say let absolute directory path is the test directory path, and we'll combine it with the test directory, okay? That path. So we'll create that little one there, test directory 1, and we just give absolute. We'll just shove it in here, okay? All right. Absolute directory path. Okay, it still just doesn't get it. Okay, so that's good. So let's call it directory 1. Oh no, we don't return anything. We just call it. Okay, create directory. Good. And that'll be the CommonFS. Exactly. So we actually don't do that. We just do fs.create directory because that looks a little bit nicer. Okay. Then, I mean, I will already assert it, right? Assert fs dot directory exists. I could do that, right? Absolute directory path. I should be able to do that. But how do asserts work in here? Where's the testament thing? Testament, and there were some thing that were displayed here. Assert this, and then I guess assert error message. Okay, so we make sure this is true. And after comma, we just show what to show when the problem occurred. So we do this exists should return true, and basically directory was not created when using absolute path. Okay. And then we can do fs.set current directory. And okay. And then we basically provided this test directory path. Okay. Oh, okay. Let's rename it instead of absolute directory path. Directory 1 absolute. And let directory 1 relative will be test directory 1.path. Okay, that will be the relative path. So we can just construct it this way and it will be a little bit nicer. So we do this and absolute. And then we can set to directory 1. Wait. What was it? Test directory path. Okay, so we set the current directory of the file system. and we create directory with the relative path. And then we should be able to test the whole thing again. Although, no, because we need to do the directory 2 suddenly, okay? Because they should be 2 different directories. Test directory 2, and bam, and bam. And directory 2 absolute needs to be calculated as well. Okay. All right. Directory was not created when using relative path. But now another thing is we should be able to just give it that thing. So what if I'm gonna just do a quick test and test if it actually works or not? So before we do the stuff, let me just call it here and try to execute the test, okay? Import new OSFS, new OSFS. That's good. From here, just FileSystem and create. Do we even need FileSystem? I don't think we need FileSystem here. We need the set current directory and remove directory. Oh no, we don't need to remove. It's just directory exists. Okay. Now we're good. So how do you run it? Where was it? Okay, run just that. Testament pattern. Do we have it installed? Well, let's see. I'll run that. Pass. Okay, okay, we've got progress. Something passed. This whole thing got executed. When I run it again, we have test directories here. Nothing. I'll run it again. I guess for a split second it was here. All right. Okay. Cool. So maybe instead of doing test directories, let's do temp/test directories. Save it. Run again. There we go. We've got a temp. This way we'll be able to add temp to git ignore or something. Okay. Let's remove test directories. We've got that here. Cool. Cool, cool, cool. So let me just double make sure that if I want to get the relative path to the directory is this, if that properly combines them together. Or maybe I'll just do it like, you know, create with whatever we created initially, but test it with something like this. Because in theory, they should still work properly, right? Let's run it. Okay, it still works. So I can just get rid of this whole thing, get rid of this whole stuff, and it's just a little bit cleaner. Okay. That works with me. All right, we just tested the if directory is properly created. Okay, and we actually kind of did test if it exists. All right, so that's good. We just did our first test. All right. So I think this is where I'm going to finish today because I'm getting a little bit tired. I had a long day. And as we're going through that, we already completed the checking if creation is fine. I guess we should also check for another thing before we go. More like, let's say we define another directory, like test directory 3, okay? We'll call it come on, go away. Directory 3. Okay. But what we're gonna do first, we're actually gonna create a file first. So creating files, what did it look like? Open and close, okay? And open and close was, I don't know where it's defined, we'll see. So we'll do open, and we'll give it the absolute path here. We write and close it. So we'll basically create a file with the same name as a directory, and then we're gonna try to create a directory with the whole absolute thing, okay? And then basically I mean, it shouldn't even get to here because this should throw an error, throw an exception. So we need to figure out how to capture that part, that hey, we're expecting an exception here. So that's that, and I guess let's make it directory 4, okay? Directory 4, because we should copy this thing with the absolute path, and let's call it directory 3, okay? Because here we created the directory, and that's all good. Then we use the relative because we set the current directory for the file system. But then we want to check the same thing when we already have the relative path. When we have the relative path set and we give it the absolute, okay, it should still properly be created, as in ignore the whole default thing if we give it the absolute path. Okay, I hope that makes sense. So let's do creating using absolute path. This will be using relative path. And then creating using absolute path when current directory is set. And then we'll be creating a directory where a file of the same name already exists. Exactly. And this should show an exception. Okay. So we have our number 4, it's all named, uses 4, creates the thing. Cool. Okay, let's see what happens when we run it. Bam, there we go. Okay, there's a lot here. Okay, so fail, that test. Failure. Exit codes differ. Expected 0, got 1. And it shows current directory test number 43. There we go. That's where it should be. Error, unhandled exception, failed to create. And that's it. And we got some difference, no new line, blah, blah, blah. The output fail. Okay, and this is what we got. Cool. So if we have all that set, now we can figure out how to actually test for an exception. All right. So let's just finish off with that. Unit tests and whatnot. And then hints, warnings, and errors. Testing the line, column, kind, and message of hints, warnings, and errors can be written in line like this. I still don't understand that. So this should have an error message, not defined equals not defined, right? Not defined is not defined. Okay. I like, like should throw or something like that would be very handy, but I don't think we're gonna find that. Let me just check in the meantime with Discord. No answer yet. Okay, I guess it's the middle of the night, so nobody is gonna answer me right now. I like the capabilities. I just like to have it all just in that one test and being able to just detect that, hey, this little thing expects an error to happen. And, just continue on after that. Inline hints, warning, and errors. As in notes. This is just notes. Warning. The opening marks the message line. This marks the message column. What's gonna happen if I'm gonna just copy that? What the hell? You go away. And one of them gonna just place that here. And save. It just shows us a warning, okay. What if I'm gonna run it now? Same thing, it just doesn't care about the warning. Okay, not sure what the purpose of those is right now, so let's just ignore it. Let me just check something else quickly. New tab. Let's do something like nym. Awesome nym, okay? Maybe there are some test frameworks here that we could quickly utilize to actually figure something out. Resources, is that the one? Yeah, 2 weeks ago. Blah, 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 blah. Error handling, macros, data, text, multimedia, algorithms, user interface, web, game development, development tools, testing, Baker, balls, a unit test, macros, save the world, or at least your Sunday. Well, look at that. A unit testing library by Python unit test complements the standard unit test module in nym to allow testing asynchronous code. Don't care right now. Unit test 2. And a module focusing on parallel test execution. Okay. Let's look at those. Okay. 2 weeks ago, so it's still alive. 2 things. A unit test DSL that helps debug tests that do not compile. And the test runner similarly expands the test matrix. Okay. Usage. Oh, you actually use it as in run balls and it shows a bunch of balls. Okay. Okay. I just hope that test library usage. Here's a set of example tests which will pass and fail in interesting ways. So looks like okay, so it's just a bunch of macros. Okay. So you define a suite of tests. Okay. You have straight up setup. Sub blocks work like you expect. Okay. Then we can define a block called goats. This is a test of goats. Oh, so block is an actual test. You have setup and then test. Setup. Oh, also you can redefine them whenever. Interesting. Another test. Teardown. Teardown works the same ways for both, I guess. Still not sure. So doesn't mean that it does this setup just for that test, and this one just for that, and teardown is for just that, or for just for the last test, or for both, or what the hell? Define them whenever. Two blocks, and then we define something. We do another block, a bunch of random tests. Doesn't mean that setup and teardown is between every single one. It's a nice comment, whatever. Really nothing else here to say. So this is be out of the block. Check. Okay, this is a bit confusing documentation. Hide this gory one statement. Okay, well, the block hides it or something? Blah, 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 blah. And this is a test of goals, a test of pigs, blah. Sometimes wolf is nice, and we just have those failed. Sheepies, value error. Where do we have sheepies? Sometimes the wolf is nice. Okay, that's the name of the test. And then we had sheepies, and it did that. So it basically runs them. Okay. Blah, blah, blah. Okay. This is a nice comment. Blah, blah, blah. Block is fine. Broken compile. Hide this gory one statement. Oops. Okay, this is a lot of examples. The define danger enabled to show the performance metrics. No failing tests are permitted in such build. Okay, all that. Interesting, but this is like a whole separate runner. I must say that I like it because it shows you as it goes and it provides those nice little things. What was it? First, it has built in for setup and separate blocks that will be decided and showing up, so you can just add them as you go, which I really like. It has, you know, assert, check, true, that wolf is very nice. Sometimes the wolf is nice. And check, true, that wolf is very nice. Okay, so that will just print it out, that check. Sometimes the wolf is nice. Okay, it won't print it out, it just checks it. Okay, and doesn't print it? So how does it differ from assert? The whole check thing. No idea. Raise new exception, of course. Check RS3. Checking some things. This block exists only to test inclusion of comments in the test code display. Oh, because we have the double here. Gosh, I like this so far. I like it, kind of. Yes, I like it a lot, kind of. I don't know, whatever. Okay, checking some things. R is 3. And that showed error. Oh, checking some things. Blah. Oh, okay, so we... Oh, so all the double like documentation comments actually show up. Check R echo will not be output. Oh, so look at that. What did we do here? We did that. Where's the R4 coming from? Because this is not showing up anywhere. If R is 3, and we check for it, and it's a checking for this and that, and R will not be output. What the heck is going on? Here, check. R should be 4. This naming is confusing. Because we have proc equals from. Var R is int is 4. Just inputs those randomly, checking some things. R is 3, blah, blah, blah. And then suddenly inside we have this whole thing. Checklist statements, block. So let's just quickly glance over other stuff. We did all those. Okay. Block is fine. Okay, so we have a separate testing rather than block. What? So what's the point of those if you can write test? Block omission, you have the whole skip thing. Guess you can jump out of that. Hide this whole thing, but it wouldn't be printed in the first place. And specifies another suite. Ay, this is like total mess. Why am I even reading it? Yeah, assert, check, report for expression expansion, checkpoint. And again, it doesn't define any differences between those. Expect value error. But expect is just like for try catch. So I guess it works here. For block, blah, blah. Expect value error. And you do this thing. Great expectations. An unmet expectation. Expect this. And it doesn't do that. Whatever checkpoint is. Dashed expectations. Check false. The truth hurts. What the hell? So I wanted to see this whole expect check. Great expectations. So some of the last ones. Great expectations. Just good. Then we have the here comes the trouble and unmaxed expectation. Expected value error, but who knows? Dash expectation. Confusing. And you have the whole documentation of it. Check one or more expressions in a block. There isn't an okay. We'll get to that at some point. I guess I'll need to read more about it. Unhard means unit in German. Unit test library inspired by Python. But is it used for the whole thing? What about the unit test 2 library? Says Matty J. I have it opened as the next one to check out. Because, I'm just really learning how to write tests in NIM. And right now, I don't know if you were able to see some of the previous code. But the thing is that, where's my code? Here. I started using the whole, what's it called? Not Terminator. The Testify. right? Yeah, testament. And, it just does stuff. But suddenly I'm like, okay, I don't mind doing that, just very basic stuff. But how do I test for an exception? And I couldn't find that, when I have stuff mixed up, how do I test for an exception? Couldn't find it. So now I'm quickly going through some other test runners and whatever was recommended in Awesome NIM, and just reading through that to see if there's something that I could use. And testing script NIM. Oh, okay. So basically the usage of this Einhard would be install it, of course, and then you just compile the scripts one by one, really. And then you can find the sits. Seriously, I need to do one by one? What's the point then? The whole idea is that I would want to run a bunch of them. Unit tests. Bam. 3 out of tests passed, and this and that and that. Not sure if I get this one right now. Let's look at the unit test 2. Beautiful and efficient unit testing for NIM evolved from standard library unit test module. Okay, it was updated last month, so that's not bad. Features beautiful, compact user experience. Okay. Test separation with each test running in its own procedure. Strict exception handling with support for exception tracking. JUnit compatible XML test reports, that's nice, and two-phase execution model as building block for advanced test scheduling and reporting features. Whatever that means. Okay, so you just install it, add its dependency, usage. Create file that contains your unit test, okay. You import it, define a suite and a test, and you do your checks. You compile, again, the test itself. The unit tests, or just a test. The generated tests have a few command line options that can help you with. Again, it just specifies test.nim. Where did that come from? Is that the file that I just created? How do I run my 3000 tests that I have? Has 2 modes operation, 2-phase, collect and run, and a single pass compatibility. Collect mode, 2-phase runners used, discovery, blah, blah, blah. Porting code from unit test. I still don't like it. Something tells me that I wonder if I could use something like that with the testament, the thing that is used to test the whole NIM itself. Again, it doesn't say much. See the tests for more examples. NIM config, nothing here. TUnitTest.nim. And we have this whole thing, sudo only tear down some. Okay. Import all that. You have a bunch of stuff with setup, tear down, all that. Another suite. And those suites are calling those procedures. Server new string. Oh, okay. Tests using backdoors. This kind of test should be executed first. Okay, some stuff here, while here we have some other procedures that would be considered, I guess, Other tests. Oh, this is a proc. And this is a test that uses to do things. I don't know why, but this just looks like a mess. I like when things are nicely structured. Unless the nature of examples is to be messy and confusing. Okay, we know those things exist, but right now I'm pissed off because none of them show a nice way to run a bunch of tests. Other than balls, which was really, really confusing. So let's just do something different. Because right now we're expecting that this code here will throw an exception, right? So I guess I could literally try to do it, okay. And if it passes, assert false. Exception was not thrown on creating directory. Look at that. Oh, the copilot already knows that this should be here. And assert eMessage is gonna create directory. I don't care about the messages. I just want to, if there was an exception, I want to assert that nothing was created, okay? Directory exists is false. Directory was not created, and that's good. Let's just save it and call it a day for now. It's a dumb way to test it, but let's see. Fail. nimc crash. Okay, what does it crash? Create cannot raise file system error. What? Where did that come from suddenly? Did we delete some data? It's all still here. Unless it's just unhappy that we got some kind of warning? No, these are just hints, okay. Failure. One passed and one failed. What? Where did it fail? Failure. Total 1, passed 0, shipped 0, failed 1. Oh, total 1 of tests and 1 failed. Okay. Oh, here, undeclared identifier E. Oh, okay. Wow, so easy to read. Except what should it be? Catchable error as E. Okay. Save it and let's run it again. Okay, now it worked. Okay. That's good. So that finally concludes our thing. And we don't even need to have as E. We can just have the whole except and that's it, right? Shorter. Good. So let's call it a day for now. We fully tested the create directory, including a situation where there's something already there. I guess we should also have creating a directory of the same directory that this when not a file but a directory already exists, right? So let's try that. We already should have directory number 1. So let's try that again, okay? Create this. Okay. And we should not have an exception. It just should be like that. Directory was not created when using a relative path. No, it should be like that. I guess let's do the try catch, right? Oops, try this and I'll be fine. And we'll do except. We'll do assert false. Exception was thrown when creating a directory with the same name as a direct that already exists. It should not have thrown an exception. Okay. I mean, that's obvious. Okay. Cool. So let's just call it directory 1 and not relative. It will be absolute. We can reuse it here and call it again, right? Still, everything nicely passed. Okay. Cool. So now that's all done, let's just commit our code and call it a day. Here. So let's see. In our CommonFS, we defined a lot, okay? I won't be even divided into separate little things. In our OSFS, we implemented all those as well. Test results, pattern JSON. I guess that's something to ignore. Test directories, and we should have current directory tests. It's another thing. And the usage.nym changed a bit as well. So let's just ignore all the git ignores. I'm gonna fix that later as I'm just tired. I need to go to sleep. Implement file operations. Create. Let's do the test as a separate one, right? Okay, on stage test. But we'll do implement file operations, ensure automatic path checking, whatever. That's good enough. And therefore, we'll just do this test. Implement basic tests for create directory operation. And let's just put it OSFS for now here, because it's kind of related to that only. Okay, let's push it so it's visible to the rest of the world. If somebody wants to get the code, again, it's available at. I'll find my browser. It's available at on GitHub, xconti/CommonFS. The link will be in the description of the YouTube video. That's it. Again, I want to thank you for watching. I hope that you were able to learn something as I'm learning myself. And feel free to like and subscribe, follow on Twitch. You can also leave comments after the stream is already posted. I will always answer them. And later this video might be divided into some smaller chunks. I don't know if those videos will actually be divisible into some decent content, because it's just me messing around and figuring things out. Don't know how to make, video content out of that, unlike the tutorials that I'm still slicing up. But yeah, that's also so far. Thank you for watching, and See you on Monday.